Alright, so continuing in the realm of imaginary numbers, we get to what we call complex numbers. Now, a complex number is simply just a polynomial or an expression that is a combination of a real number and an imaginary number. So, a lot like combining terms in the real number system, imaginary numbers and real numbers cannot be combined in that they cannot be added or subtracted. So when dealing with expressions that have both real numbers and imaginary numbers, they can be simplified, always be simplified down to this as their simplest form, where we have the real part and the imaginary part in the form a plus bi. So a couple examples of what look like are here. So 3 plus 5i. Imagine that I is a variable. We can't add these together. They're not like terms. So this is as simplified as this expression can get. Same thing with these two as well. But what we're going to look at in this lesson and what you're going to begin to practice is computation, is arithmetic with combining our knowledge from the real number system and how we operate with the distributive property and combining like terms, and also what we previously talked about with the imaginary number system. So a pretty basic example, first of all, just combining like terms. When we combine like terms in the complex number system, we're going to do this the same way that we would combine like terms in the real number system, where we only combine our like terms. So we have the 3 and the 7. Those are like terms, so I'm going to do 3 plus 7, so 3 plus 7 is 10, and then we've got the 5i plus negative 2i, which is a positive 3i. So that's simplified, and that's all there is to that. So that's how we combine like terms within the complex number system. So this is a pretty basic example of what we can do. To up it a little bit, we'll multiply two complex numbers, and we'll do this the same way that we would multiply two binomials in the real number system. We will distribute. So we'll do 6 times 4, it's 24. We'll do 6 times negative 3i, treat the I like a variable, negative 18i. Then we can do 2i times 4, that is 8i. And then we'll do 2i times negative 3i, which is negative 6i squared. Now the first thing we're going to want to do is combine our like terms. Negative 18i plus 8i is 10i. 24. This is actually a negative 10i. Now here's where we have to add some of the stuff that we talked about with the imaginary number system in the last lesson. I squared. This can be simplified separately from everything else. So if you remember from the last lesson, I squared is actually negative 1. So this term is actually negative 6 times negative 1. Negative 6 times negative 1 is positive 6, which we can then combine with the 24. 24 plus 6 is 30, then minus 10i, and here is our answer, simplified down to that form a plus bi. Example here that's just a bit more complex. Again, we're going to distribute, so 5i times I, that's 5i squared. 5i times 3i squared is a positive 15i cubed. Now what we're going to do is begin to simplify this in the same way we did, again, in the previous lesson. So I squared is actually negative 1, so 5 times negative 1, which is negative 5. I cubed, let me switch colors actually, I cubed is negative I, so this is 15 times negative I, which is negative 15i. Now this is in the form a plus bi it's in its simplest complex form. So 5i times I plus 3i squared is negative 5 minus 15i. So we have this complex expression in its simplest. So let's look at one more, the most complex of the ones we've looked at so far, just combining all of that information. So we'll start with the distributive property. I cubed times 2i to the fourth is 2i to the seventh. I cubed times I is a positive I to the fourth. And then we have our plus 4i. So we'll begin to simplify this. I to the fourth power, if we remember from a previous lesson, I to the fourth power is actually a positive 1. I to the seventh power, we could simplify this. I to the seventh power is actually I times I to the sixth, which is I times I squared to the third power, which is I times negative 1 to the third power, which is I times negative 1, which is negative I. So this is 2 times negative I. This is 2 times negative I, which is just negative 2i. Plus our 4i. Now we have like terms here. Negative 2 and a 4 is a positive 2i. We still have the 1. And now this is in the form a plus bi. So this is the most complex of the ones that we just looked at. We had a few things going on. We began with the distributive property. Then we had to do a little simplification with the imaginary numbers and the exponents like we did in the previous lesson. I to the fourth is 1. I to the seventh is actually, we see that here, is actually negative I. So we simplify that, finish by combining our like terms, and then now we have this in the form a plus bi. So moving on from here, what you're going to do is take some notes that are in Canvas, and then guide. There's some practice in the book that you're going to do that I've got some examples to guide you through, and then complete the work in Canvas moving forward from this. Also, in Canvas, there's a couple extra videos with a little more advice, with some more tips and examples if you need that. All right, good luck.